Hey everyone, I'm Csaba Kozak, and I will be talking about annotation processing for Kotlin today. So that's the agenda for this talk. I will quickly introduce myself and why I'm working in annotation processors. Then we'll see what is annotation processing itself. And a little bit later, we'll dive into under the hood, so see how annotation processors actually work. And finally, we'll see how this is working in Kotlin and what the difference for annotation processing compared to Java. So a very quick introduction about myself. So currently I'm leading the Android developer team at Supercharge. This is a mobile developer agency in the capital city of Hungary. It is Budapest. And I had several experiences with annotation processors. I'm leading or maintaining the Android annotations library. I'm not sure if anyone used that library in this audience. Maybe, okay, it is one person. So, okay, so it was a kind of a popular annotation processor back then, but because of Kotlin, it nowadays kind of deprecated. Anyways, I was involved in annotation processors by maintaining them, and also we are using a lot of annotation processors, I guess, as you do at our day-to-day work. So this is why I'm involved in annotation processors, and this is why I'm talking about those. So let's see what is annotation processing. This is basically some kind of a code generation method. There are several ways to generate code, and annotation processing is one of them. This is our main topic for today. So annotation processing basically can generate source code at compile time or beat time. But there are other ways to do this kind of job. You can also use Kotlin compiler plugins, which can read your source code, but these are generating bytecode at compile time. And so basically they are checking your code and replacing parts of your code. If you are using the Android extensions and parcelize, that library is implemented using Kotlin compiler plugins. Also, you can use runtime bytecode generation. In contrast to the first two methods, that's not in compile time but runtime. This means that parts of your code are not shipped in your APK or Java classes, but these are generated in runtime. This is how, for example, lambdas work on the JVM, or how most of the mocking frameworks are doing their jobs. Also, you can use reflection for these kind of problems. Reflection is not really a code generation method, but it can replace code generation and basically do the same job. However, reflection can be slower, especially in Android. So this is why we are using annotation processing on Android, because it can be much faster than reflection. However, reflection is a very popular method in the backend side. So to understand annotation processing, we have to understand what's an annotation first. So basically, it's a piece of metadata or note or marker which can be added onto your Kotlin or Java code, so you can add more information to it. It can be placed on most of the language elements, so you can place it on top of your classes, functions, properties, etc. Annotation can be useful by itself, but you can also add parameters into it. If you only have one parameter, then you can just pass it very simply, like in the second example. But if you have more parameters, then you have to explicitly write the parameter names and then the values. The annotations then can be read by either compile time, using the compiler, or runtime when your application is running. However, because of the compile time restriction, you can only pass compile time values. So if you have any values that are calculated at runtime in the application, for example, if the user entering some data, you just cannot put that into the annotation, because that annotation has to be read using the compiler. And what annotation processor? So basically, the annotation processor looks for these annotations throughout your code and takes those annotations as its input. And then it can generate several things, either source code or resources, or even bytecode or class files. However, it can not just generate code, but place compiler warnings or error messages, just like the normal compiler is doing. However, there is one big restriction. It cannot modify existing code. it can only generate new ones, so basically new classes or functions. And why to use this kind of code generating method? So code generation is used for replacing or automating tasks which are very boring or a kind of boilerplate code or repeated tasks. So developers don't have to do them always and always for each project. They can just annotate the code, and the annotation processor will write the real code behind them. Also, it is very good because you can catch the errors at compile time. So if you make any errors using your annotations, the annotation processor can check those annotations and place compiler errors on your code. So this way, these kind of errors will never reach your users because your CI or your compiler will fail. Also, this is not really a magic because the annotation processors are generating source code. This can be read by humans or programmers and check what is generated. And also, debugging breakpoints can be put into the generated source code, and actually you can debug through the code, so there will be no black box all of the information. Annotation processing is kind of fast because it's generating source code. It can be as fast as you could write with your hand, and it can have little compilation overhead. However, you can see that it can change, especially with Kotlin. Annotation processing can have several use cases. I listed some libraries that are using annotation processors. Some of them are Java libraries, and some of them are Kotlin libraries. The first is outValue. This is for Java. It can generate value classes for the JVM. However, this is not really useful for Kotlin because now we have data classes. Butternut is an Android library. It can generate view and resource successors. And the data binding framework for Android actually uses annotation processors in the backend. Dagger is a dependency injection framework, and it is also an annotation processor. It can be used on Android or the JVM. Moshi is a JSON parser, and it has an annotation processor, so you can generate your JSON editors at compile time. So the JSON parsing can be much faster than the reflection way. Also, the Room is a ORM, a database library for Android, and it also using annotation processors to generate the database accessor source code. So as you can see, there are a lot of different annotation processors you can use. But how does actually work under the hood? My talk is about Kotlin annotation processing, but I will be talking about Java first. This is because the Kotlin annotation processing framework is built on top of Java. So to understand the annotation processing in Kotlin, you have to understand the Java, how it works in Java first. So the annotation processing is the part of the Java compiling process. When you have annotation processors, and the compiler will first process the Java code, so you parse the Java code as usual, and then it will create a model of it. The model will only include the structure of your code, so only the classes, the functions or properties, but not the implementations inside the function. That is not available to annotation processors. And then it reads the annotations and of course this language model, and it will pass it into the annotation processors. Then this can generate some code based on the input, and this code can also include more annotations, which can be processed. So then a new annotation processing round will be called, and this is repeated. This cycle is repeated until there is no more annotation generated, or an error was raised during the compilation. After all source code is generated, the compiler will resolve with the normal compilation of the sources. So this is how it is working in Java. If you want to implement an annotation processor, you have to subclass this abstract processor class. It has several functions that you can override. The init function will be called when the compilation is starting, where you can do some initialization of your annotation processor, and the processing environment will be passed in. We'll see the processing environment and other classes later. With each annotation processing round, the process function will be called, you will see the annotations that you can process, and also this environment that the current round is in. You can override the get-supported annotation times function, so you can specify which annotations do you care about. If you return a star here, that all the annotation will be passed into to your processor. If you have any options or flags, you can override the get-supported option function, and you can return a set of options. Then your users, who are actually developers, can pass, and these can alter the behavior for processor. So let's see what are the API of the annotation processing. As you could see, the abstract processor class has to be subclassed. And for the start, the processing environment object will be passed in. There are two main parts of this processing environment object. The first is the filer. The filer is used to write out source code or resources. It is very important that annotation processors can only use this entry point to generate source code, since the Java compiler has to know which is generated, because then the Java compiler has to actually compile the source code. You can use this interface. To present compiler errors or warnings, you can use the messenger interface to put some errors or warnings on the code that if the developer needs some problems with the annotations. For each annotation processing round, the round environment object will be created. There are several flags which can indicate whether the processing will be over in this round, or an error was raised in the previous annotation processing round. And with the last two functions, you can have the annotations and the elements of the structure of the code that you can deal with and process. And the whole source code will be modeled in the element interface and the subtypes, so you can visit the code and generate some generated code based on it. However, as you could imagine, this whole code generation can have an impact on your build speed. First of all, there is an override of the processing framework. The Java compiler has to discover all of your processors and pass the model into those. Then actually the processors has to run. They are visiting the language structure, and they are also generating source code using I/O. So this also takes time. And there is a very big problem with annotation processors that, at least in Gradle, incremental compilation is turned off if any annotation processor is found on the class path, at least by default. However, since Gradle 4.7, you can enable incremental processing with Gradle. So each and every annotation processor can opt in whether they support incremental compilation or not. There can be two types of incremental annotation processors. The first type is isolating. This means it can only look at one part of your code, basically one class, and then generate another generated class from it. For example, if you are a dependency injection framework, an isolating processor could be a factory generator, so it can generate factories for your inject point. The other type of incremental processor is aggregating. This means it can look at multiple source codes and then generate one source code from it. For example, if you still have a dependency injection framework like Dagger, this means that it could generate a dependency injection graph based on several classes. However, you have to be aware that if you have incremental processing or compilation, that only the smaller subset of the code which is new will be included in the annotations and the language model for your processors. So the whole class path field will not be available. This is why it is hard to write incremental processors. Also, if you have at least one non-incremental annotation processor, then it will kill the whole incremental compilation, unfortunately. So you have to make sure that all of your processors in your Gradle models are incremental. If you see this warning, this means that the incremental compilation will be turned off for your whole module. So you have to look out for this kind of warnings and try to fix those processors which are not incremental, or move them to other modules. So we saw how it is working with the Java language, and let's talk about Kotlin. So in Kotlin world, the annotation processing tool is called KAPT. This means Kotlin Annotation Processing Tool. It is very funny because actually the Kotlin Annotation Processing Tool is implemented as a Kotlin compiler plugin. How it is working in Kotlin? It has extra steps compared to the Java compilation. So because of this, it can take much more time. What are those steps? The first, the Kotlin compiler has to parse the Kotlin sources, as usual. However, there is an extra step because the annotation processing is a Java thing, so it is based on the JDK. It can only understand the Java code, the Java language model, and the Java structure. It cannot understand Kotlin code. So to bridge this problem, to bridge the gap, the Kotlin compiler will generate Java stubs from your Kotlin code. So this means that it will look at all of your Kotlin classes, remove the implementation inside the functions, and generate a Java stub and pass that into the Java annotation processing framework. We'll see how the stub generation looks a little bit later. So after the stubs are generated, which are plain Java source code, and actually you can look at them inside your build folders, then the Kotlin compiler will call the standard Java annotation processing that we previously saw. So it will show the processors, and there will be only one processing run, so there is no multiple runs as you saw with the Java annotation processing. And all those processors are running, and at the end, they can either generate Java source code or Kotlin source code. Obviously, if you have older processors, it is possible that they are still generating Java source code, so it's very much a possibility. Unfortunately, if they are generating Java source code, then the Kotlin compiler has to call the Java compiler first to compile those Java sources into Java bytecode. So there is also an extra step in the Kotlin annotation processing. And at the end, as usual, the Kotlin compiler will look at the Kotlin source code and compile it into Java bytecode. So let's see how this stub generation is working. So we have a very simple and boring class called greeter, and it has several properties and one function. And as you can see, there are inject annotations on it, so annotation processors can process this code. And the Kotlin compiler will look at this class, and will generate this Java stub from it. As you can see, that the method bodies or function bodies are removed, and only the structure of the code remained. Since the annotation processing is only caring about the structure, that's perfectly fine. That would be unnecessary extra work to generate the implementations. However, since the Java language is generated, so Java stub is generated, and Kotlin can include much more language features than Java, information could be lost. So how your annotation processors can actually look at what Kotlin language features that you use for your source code. To have that, there is a very special annotation which is called Kotlin.metadata. So this annotation is not intended to use by developers. This is added during the Kotlin compilation, and it is containing metadata about your Kotlin code and the Kotlin language features that you used. The syntax of it is very magical. You should not be able to read this by hand, by yourself. However, there are tools which can extract the information from it, and if you use those tools, and you can extract the Kotlin language features that are used in your class, and then you can process the Kotlin code, and you can actually emit Kotlin language features based on those Kotlin language features used in the source code of the developer. For example, you can generate, if the developer uses the extension function, then you can also generate an extension function. So as you could see, the Kotlin annotation processing is using more extra steps compared to Java, and unfortunately this means more build time for you. if you compare the standard Java compilation and adding annotation processing to this, there is only about 10% overhead, of course based on how big processors you have. But unfortunately, if you add annotation processors to Kotlin code, then it could be almost as double time than if you don't have any annotation processors in your class path. This is by default, and we can mitigate this overhead with the next steps that I will show you. So, how to add Kotlin annotation processing to your project? First of all, you have to apply the Kotlin kapt plugin. Then you have to list all of your annotation processors with the kapt configuration in the dependencies block. It is important that you add kapt and not annotation processor or implementation here, because the Kotlin compiler has to know that which are your annotation processors explicitly. Also, if the annotation processors are having options that we've seen previously, you can pass options to them using the arguments block. Also, it is wise to add this Java C option xmaxers to a very big number. Since annotation processors can generate lots of errors if something goes wrong, you should be able to see all of those errors. However, the Java compiler has 100 errors. Number of errors could be 100 by default, so you should raise that number to a very big number so you can see all of the errors. You can add actually int max value here so you can see all of the errors. Also, you should use the latest Kotlin compiler, since it should have the latest and greatest features and its speed should be the fastest. And actually, incremental annotation processing is enabled by default since Kotlin compiler version 1.3.50. Moreover, to further enhance your build speed, you can include more Gradle properties flags. The first flag is called kapt include compile class path. You should turn this to false. And this will mean that the discovery of the annotation processors will be turned off in your class path, and you have to explicitly mention the processors with the kapt configuration as is in the previous slide. However, this will enable compilation avoidance for your modules. So this means that if the module doesn't have to be rebuilt, this can be avoided. But it can be only done if you enable this Gradle properties flag. The second flag, kapt use worker API true. This means that Kotlin annotation processor tool will use the Gradle worker API, which will means faster build times for you. And the last flag should have with a project that can have multiple modules. So if you have multiple modules, then those modules can be parallelized in terms of build. And if you enable this flag to true, then the Kotlin compilation can be parallelized as well. So your Kotlin modules are actually compiling parallel. Also, if you have annotation processors, and if you are watching this talk, then you should check all of them, the readmes or GitHubs, and you should see that if they are supporting incremental processing or not. It is possible that they are supporting it, but you have to explicitly enable it using annotation processing flags. For example, room has to be set to be incremental, but there are other processors that still are not incremental by default. And unfortunately, there are still processors that are not incremental at all. To deal with those, you can move those processors, if you can, to a smaller Gradle module. So this means that only a very small part of your code is recompiled always, and the other part of your code, all those modules, are not affected by not incremental compilation. So again, how to mitigate the overhead of the Kotlin annotation processing. So you should use and write annotation processors that are generating Kotlin code. So as we see that if there are Java code generated, then the Java compiler is called, which also extra time. We should avoid that. And make sure to process incrementally. To do that, please check and enable incremental processors. You can leverage compilation avoidance, and you can scope the annotation process to the smallest module. This can be useful because the Java stub generation is done for all of your source code. Even if the source code or classes are not including annotations, they are still stubs are generated from them. So to have a smaller build time, you can move the annotation processing code to a smaller Gradle module. So this means that only a part of your Kotlin code will be read and generated stubs from it. If you are writing annotation processors, you don't have to reinvent the wheel. And there are lots of libraries which can help writing processors. The first is a library by Square. This is called Kotlin part, and then this can generate Kotlin code easily. The second is Autoservice. It can be used to wire up annotation processors. Incap can be used to write incremental processors more easily. And Kotlin metadata is a library which can extract the language features of Kotlin from the Kotlin.metadata annotations in a type-safe manner. And lastly, there is Kotlin compile time testing. I guess all of you are doing some kind of testing, and this should be done for annotation processors themselves as well. It is very useful since if you are generating bad code and you are not testing it, it can hurt a lot of users. So you should test annotation processors. To use that, you can use the Kotlin compile testing artifact. Let's see two examples for the first and last libraries. To write or generate Kotlin source code, this can be a very small example. So this example is generating a greeter class. You always start with this file spec because every class obviously have to be contained in a file. And then you add the type, functions, properties, function implementations, etc. And finally, you have to write the whole thing out to some place. In case annotation processors, obviously, of course, as we seen previously, you have to use the filer interface to write all the files. But if you are just doing some testing, you can write it to system out as well. And for testing, first you can create, or you should create source code which are containing your annotations. Then you can actually call the Kotlin compiler, which will compile the source code and call the annotation processors and generate source code. After it, you can inspect the exit code or the result of the compilation, check what messages are generated, and also you can check which code was generated from your processor. Kotlin is going multi-platform nowadays, and this is a very big topic for Kotlin. However, as I said, that annotation processing is a JVM thing. It is based on Java. And unfortunately, annotation processing cannot be used. Kotlin annotation processing KPT cannot be used for multi-platform projects. However, there is a new tool. This is called MPAPT, which stands for Multi-Platform Annotation Processing Tool. So this is a new library which is very similar to the Java Annotation Processing API. The interface of it is copied from the Java Annotation Processing API. However, it can target also native JS platforms and also the JVM. So this is a very new project. There are only two known annotation processors used and with the help of this. But I expect as Kotlin multi-platform matures, and that there will be more annotation processors that are multi-platform. Finally, let's see some useful links. You can learn more about annotation processing either by writing annotation processors or just using them using these links. Thank you very much for your attention. I hope that your developer experience regarding annotation processors can be better using my talk. And if you have any questions, I think we have time for some Q&A. Thank you.